Okay, this is chapter 7.4, properties of special parallelograms. Essential question, what are the properties of the diagonals of rectangles, rhombuses, and squares? Recall the three types of parallelograms shown below. So a rhombus is like a square, but it's the top, if you could picture it, just pushed over a little bit. All four sides are still congruent, but this angle is greater than 90 now, and so is its diagonal, and this angle's less than 90, and so is its opposite, okay? A rectangle is a four-sided figure where opposite sides are congruent and parallel, but all four sides are not congruent. So the length is greater than the width, but actually a square is also a rectangle, but a rectangle in general is one side's longer than the other, removing it from the square category. And squares are all four sides are congruent and all four angles are 90. So what you will learn in this chapter is use properties of special parallelograms, use properties of diagonals of special parallelograms, and use coordinate geometry to identify special types of parallelograms. So let's take a look. Okay, core concepts and some corollaries here before we get started. So rhombuses, rectangles, and squares. A rhombus is a parallelogram with four congruent sides. So I've already mentioned this. A rectangle is a parallelogram with four right angles, and a square is a parallelogram with four congruent sides and four right angles. So rhombus corollary says a quadrilateral, four-sided figure is a rhombus if and only if it has four congruent sides. So ABCD is a rhombus if and only if segment AB equals side ABC equals segment CD equals side AD. There's a proof, example 81, page 396. The rectangle corollary, a quadrilateral is a rectangle if and only if it has four right angles. So since a square has four right angles, it is a rectangle. ABCD is a rectangle if and only if angle A, B, C, and D are right angles, which are 90 degrees. The proof is example 82 on page 396. And corollary 77.4 says square corollary. A quadrilateral four-sided figure is a square if and only if it is a rhombus and a rectangle. So what's a rhombus? Four congruent sides. A rectangle, four right angles. So in other words, a square is a quadrilateral and a rhombus because it has four congruent sides and four 90-degree angles. So ABCD is a square if and only if side AB equals BC or is congruent to, and is congruent to CD, is congruent to AD, and angle ABC and D are right angles. The proof of that is on example 83, page 396. So let's take a look. Okay, before we do example one, let's take a look at this Venn diagram. It's a really good way to identify where things go. So a Venn diagram takes a set of things and breaks them down into what are called subsets. So this big, huge rectangle here, everything that's in the parallelogram family is shown on this screen. So if you have a quadrilateral with two pairs of parallel sides, like this one and this one, then they're parallelograms. But then we get into more specific ones where we have four congruent sides. Obviously, this side is longer than this one, and this side here is longer than this side. So now we're getting to two shapes that are four congruent sides. So this has four congruent sides and opposite sides are parallel, and those are rhombuses. And a square is four congruent sides, but the angles are all 90 degrees. So a square is a rhombus because by definition, a rhombus is a quadrilateral, four congruent sides. So a square has four congruent sides, so it's a rhombus. A rectangle is a quadrilateral with four right angles. So these are not rectangles because their angles are obtuse and acute. Okay, so a rectangle has four right angles, but so does a square. So squares are not rectangles, but rectangles are squares. So the square is a special shape that is a rhombus. It is a rectangle and it is a parallelogram. Where rhombuses are parallelograms, but they're not squares. Rectangles are parallelograms, but they're not squares. Okay. But a square is a rhombus, rectangle, and parallelogram. All right. So now with that being said, let's take a look at example one. It says use the properties of special quadrilaterals, and we have a rhombus. Okay, so for starters, we're going to identify what we're talking about. Rhombus QRST. Decide whether the statements always or sometimes true and draw a diagram to explain your reasoning. So I'm going to get my ruler. And what do we know about rhombuses? Well, they have four congruent sides. So I am going to draw a shape, and let's just go out 3. So that's 3 centimeters on my ruler. And then I'm going to rotate the ruler. It doesn't matter what the angle is as long as it's not 90, because I don't want a square, I want a rhombus. I don't want a rectangle. Okay, and then I draw this out to 3. So if I keep that very same angle, come over here and make that length 3, and then rotate this back like so, and put this here, this distance here should be 3, and that is a rhombus of side lengths 3. So this is 3, this is 3, this is 3, this is 3. I have an acute angle, I have an obtuse angle. So it is not a square, it is not a rectangle, but it has 4 congruent sides, so it is a rhombus. So if I call this Q, call this R, call this S, call this T, you should always name them going clockwise. Don't ever cut through, because you should draw it by looking at the letter. Go from Q to R to S to T. So now it says angle Q. So let me erase my angle measure things. So let me get rid of this and this. So now it says angle Q. That's still 3. Angle Q, I'm going to use blue here. Angle Q is congruent to angle S. Okay, those are opposite angles in a rhombus. And since it's just a square pushed over, remember our rule that says consecutive angles are always supplementary. So if this is 40, then this has to be 140. And if this is 140, this has to be 40. So then opposite sides are congruent. So that is always. Opposite angles are always congruent in a rhombus. Okay. So then we have Q congruent to R. So I already have the diagram here. So when is a rhombus consecutive angles congruent? Well, that's when we have a square. So if I just draw a square quickly like this and call it, let's change that color. I don't like black for my outline. Let's see. So I'll just click on here and make it, I don't know, blue, and make it thinner. Okay, so here's a square. So if I name this Q, it's a bad Q, Q, R, S, and T. Remember, squares have congruent sides, so it's a rhombus. But I can have, if this is 90 degrees and consecutive angles have to be 180 degrees or supplementary, then that's 90 degrees. So angle Q is congruent to angle R. If the rhombus is pushed over, if you will, so that all 4 are right angles, then that becomes a square, which is still a rhombus. So that would be sometimes. Okay, it's not always 90 degrees, because obviously 40 is not 90. 140 is not 90, but if these are all 90, it is still a rhombus, because by definition, a rhombus is a quadrilateral with 4 congruent sides. So now you should be able to do problem numbers 3 and 4 in the exercises. Okay, so classifying special quadrilaterals. So classify the special quadrilateral right here, explain your reasoning. So the first thing I'm going to do is I'm going to think about, okay, a rhombus has 4 congruent sides. A rectangle has 4 right angles, and a square has both 4 congruent sides and 4 right angles. So when I look at this diagram, I see 70 degrees. So goodbye to rectangles, because 70 is not 90. Goodbye to square, because 70 is not 90. We have 4 congruent sides, okay, and angles that are not 90 degrees. So this is a rhombus. And my reasoning was just in my wording. So you'd have to write that. You'd say this is a rhombus because it has 4 congruent sides and the angle measures are not 90 degrees. Okay, so now you should be able to do problems numbers 9 and 10 in your exercise. Okay, theorems 11 and 12. Rhombus diagonals theorem. A parallelogram is a rhombus if and only if its diagonals are perpendicular. Okay, so if you have a rhombus and you draw a diagonal AC and you draw the diagonal BD, then the angles in the center are perpendicular. Okay, where they intersect here, all four angles are 90 degrees. The two angle bisectors are perpendicular. So here it says parallelogram ABCD is a rhombus if and only if angle or side AC is perpendicular to BD. The diagonals are perpendicular. Okay. Rhombus opposite angles theorem says a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So if I draw the diagonal BD, it is going to cut angle D into two congruent pieces and angle B into two congruent pieces. Draw diagonal AC, and then angle DCA is congruent to BCA, and angle DAC is congruent to angle BAC. So it says here, rhombus ABCD is a rhombus if and only if segment AC, a diagonal, bisects angle BCD, BCD is right here, and angle BAD, which is right here. And BD, segment BD, bisects angle ABC, which is here, and angle ADC, which is here. Okay, so the diagonals bisect the opposite angles. All right, so let's take a look at this. Okay, example 3, finding angle measures in a rhombus. Okay, so it says find the measures of the numbered angles in rhombus ABCD. So the measure of angle, so I'm going to write these over here. The measure of angle 1 equals the measure of angle 2 equals the measure of angle 3 equals, and the measure of angle 4 equals. So I'm looking at 1, AC and BD. This is a rhombus. They told us that. So the diagonals are perpendicular. So angle 1 is 90 degrees. Okay. The measure of angle 2. Now remember, diagonals bisect. So if this is parallel, which it is, to this, AC is a transversal. And that's why we did that way back in, was it chapter 2 or 3? So angle 2 is alternate interior angle to angle 61 degrees. Okay. BAC is congruent to DCA because of the alternate interior angles. So angle 2 is 61 degrees. The measure of angle 3, remember what we just said, a diagonal bisects the angle. So this is 61 degrees. So this is 61 degrees. So angle 3 is 61 degrees. And then the measure of angle 4, well, we have to do the triangle sum theorem. So the measure of angle 1 plus the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Do the triangle sum theorem, and you should always show all your work. I stress that in class, and here's how you do it. This angle plus that angle is in triangle A. And if this was E, then that's triangle AED. So the measure of angle 1 was 90 degrees. The measure of angle 3 was 61 degrees. And we don't know the measure of angle 4. So we set that up. We have one unknown. Combine like terms. 90 plus 61 is 151. Plus the measure of angle 4 equals 180 degrees. And subtract 151 from both sides. And these cancel. And I get the measure of angle 4 equals 29 degrees. So if this is 29 degrees, this is 29 degrees, this is 29 degrees, this is 61 degrees, this is 29 degrees, and this is 90, and this is 90, and this is 90, and this is 90, and this is 61, and this is 61. Okay? So basically, if you are given a diagram like this, and you are only given one angle measure, you can find all of them. So now you should be able to do problem numbers 13 and 14 in your exercises. All right, theorem 7.13, the 13th theorem in this chapter. Whew. All right, rectangle diagonals theorem. A parallelogram is a rectangle if and only if its diagonals are congruent. So in a rhombus, if I go back to this rhombus here, get this out of the way, it's obvious DB is longer than AC. But then when I come to a rectangle, now the diagonals are congruent. So if you have two diagonals that are congruent and they bisect each other, then every half of the diagonal is congruent. So in parallelogram ABCD is a rectangle if and only if AC is congruent to BD. Okay, diagonals are congruent. So let's look at a problem that involves that. All right, example 4, identifying a rectangle. You're building a frame for a window. The window will be installed in the opening shown in the diagram. So here's a diagram. Here is a wall that someone's building, and they have the studs in the wall already there, and then they have a framing for a window. The opening must be a rectangle. Given the measures in the diagram, can you assume that it is? Explain. So I'm going to bring in this again. And what is a rectangle? A rectangle, it has opposite sides parallel. Opposite sides are congruent. And the angle measures are 90 degrees. So the opening must be a rectangle. So can I assume that this is a rectangle? So the first thing I look at is, well, 33 is congruent to 33 and 44 is congruent to 44. So opposite sides are congruent. That's true. But do I have enough information to prove that that's 90 degrees? And the answer is no. Okay. This could be off a little bit when they went to build this. Okay. This could be 89 degrees and therefore making this 89 degrees. But we also don't know that these are parallel. So we would need to know opposite sides congruent and parallel, or 4 congruent sides is just not enough. Okay. If that's 89 and that's 89, this could be 91 and this could be 91, and 1 degree off would be tough to see with the eye. So at this point, the opening, we cannot assume. So the answer to this is no. And the reason is only because the opposite side lengths are the same is not enough information. We have to know that the angles are right angles. So here's the rectangle. Okay, so I'd say we don't know the angles equal 90 degrees. Okay, all right, so let me get rid of all that mess. All right, and now let's go on to the next part. B, you measure the diagonals of the opening. So if I draw a diagonal, and let's make it a little bit thinner than that, and how about green? So then I measure a diagonal here, and I measure a diagonal like so. Okay, so we measure the diagonals, and the diagonals are 54.8 inches and 55.3. So let's make these different colors. Let's make this one blue. So the green one, okay, so if this is A, B, C, D, and the green one, let's just say AC equals 54.8 inches, and angles or segment BD equals 55.3 inches, they're not equal. And if I go back to this here, if it is a rectangle, it is a rectangle if and only if the diagonals are congruent. And so I'd say since AC is not congruent to BD, comma, the shape is not a rectangle. But can we conclude, can we tell what it is? One diagonal is longer than the other and all 4 sides are congruent. That would be a rhombus. So I'd say it is a rhombus. Okay, So the diagonals are not equal, but all four sides are. That is a rhombus. Okay, so now you should be able to do problem numbers 23 and 24 in the exercises. All right, example 5, finding diagonal lengths in a what? A rectangle. What do we know about the diagonals of a rectangle? Well, they're congruent. So AC is congruent to BD. That makes that quadrilateral a rectangle. So we're told it is a rectangle. QRST is a rectangle. So therefore, I know. All right, let's try that again. All right, QS. What is going on? I'm doing a really, calligraphy pen. Let's not do calligraphy. So QS, segment QS, or QS is equal to RT. So QS is congruent to RT. Okay, or the lengths are equal. QS, the length of QS is equal to the length of RT because it's a rectangle. Diagonals are congruent. So you write the formula, or you write what you know from the theorem, and then you substitute in the givens. So here we're told QS is 5x minus 31. So substitute. QS is 5x minus 31. RT is 2x plus 11. Substitute 2x plus 11 in for RT. Now we have two linear equations equal to each other, one variable we can solve. Subtract 2x from both sides. Always move the smaller x first. 5x minus 2x is 3x minus 31 equals 0 plus 11. Add 31 to both sides, and I get 3x. This cancels, equals 42. Divide both sides by 3, and x equals 1, 4. So x is 14. Okay, so then you write QS is 5x minus 31, which is 5 times 14 minus 31. 5 times 4 is 20, carry the 2. 5 times 1 is 5, plus 2 is 7. 70 minus 31 is 39. And then I'm going to do the same for RT. So I come over to RT. RT was 2x plus 11. Substitute in my x I found. 2 times 14 is 28, plus 11. 8 plus 1 is 9. 2 plus 1 is 3. They're equal. They're equal. 39 equals 39. It is a rectangle because the diagonals are congruent. So now you should be able to do problem numbers 25 and 26 in the exercises. Okay, example 6, identifying a parallelogram in coordinate plane. Decide whether parallelogram ABCD with these vertices is a rectangle, a rhombus, or a square. Give all names that apply. So A is -2, 6. So first thing I'm going to do is plot these points. B is over 6 up 8. C is over 4, 0. And D is -4, -2. So there are my 4 points. So this is A, this is B, this is C, this is D, and then I'm going to put the coordinates of the vertices. So A is -2, 6. B was 6, 8. C was 4, 0. And D was -4, -2. And I just noticed by doing that, I made a mistake. So let me erase this. I did not put D in the right location. It's -4, -2, which is up here. Okay. And that's what, and one of the other reasons why you should always label. I found a mistake. So it's -4, -2. Now I'm going to connect these points with a line. Let's go a little thicker and let's use red. Okay, so AB, DC, BC, and DA. Okay, so there's our shape. So just by looking at this, I can tell that that's acute and that's obtuse. So see you later, square. See you later, rectangle. Now I just have to determine whether or not it's a rhombus. So what is a rhombus? So let's go back. A rhombus is a parallelogram with 4 congruent sides. Okay, so I have to prove that each side is parallel, and I have to prove that each side is equal. Not each side parallel. I have to prove AD is parallel to BC. I have to prove AB is parallel to DC, and are they all the same length? Okay, so what I'm going to do is find the length of, let's see, how else could we do this? We could also work with the diagonals. So what do we know about the diagonals of a rhombus? Where was it? Right here. So the diagonals of a rhombus are not equal, and they are 90 degrees. So that's right here. So I'm talking about the rhombus diagonals theorem. So if that is a rhombus, if it is a rhombus, a parallelogram, the diagonals have to be perpendicular. So let's check that first. Okay, so I'm just using my theorems. So now I'm going to draw diagonals. Okay, and let's make them thin, and let's make them purple. So here's diagonal AC, and here's diagonal BD. All right, what I need to know is, are they perpendicular? So let's find the slope of both of them. So the slope of AC equals, and slope is y2 minus y1 divided by x sub 2 minus x sub 1. And this is another reason why I write the vertices, the coordinates, because then I can look at my y's and x's real quickly. So here's AC. Y2 is 0, y1 is 6, 0 minus 6. X2 is 4, x1 is negative 2. 4 minus a negative 2 is plus 2. So the slope is negative 6 over 6, which is negative 1. So the slope of AC is negative 1. Down 1 over 1, down 1 over 1, down 1 over 1, and it checks. So now I'm going to find the measure of, or the slope, I mean, of BD. So I want to check to see if these two are perpendicular. Remember, perpendicular slopes are negative reciprocals. So what's the slope of BD? I'm going to write the formula. Y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Y2 is 8. Y1 is, oops, what was that? Y1 is negative 2. So it's minus a negative 2 or plus 2. 8 y2 minus y1, 8 minus a negative 2 over 6 minus a negative 4, which is 6 plus 4. And that's going to be 10 over 10, which equals 1. So notice that these are negative reciprocals. Think of this as over 1 and think of that as over 1. They're flipped and their signs are opposite. So I have now shown that these two diagonals are perpendicular. Okay, now I want to see if their lengths are the same or not. So if their lengths are different, then we know it is a rhombus. Obviously, it's clear in this photo, but it might be not so clear in other diagrams. So we still need to check. So AC equals the square root of, and you do this, and you do this, and you do this, and it's the difference of the x's. So AC, 4 minus a negative 2, which is 4 plus 2, and y's 0 minus a negative 6, or 0 plus 6. So AC is going to equal 6 squared plus 6 squared. So AC is going to equal the square root of 36 plus 36. AC is the square root of 72. Now, don't simplify that. You can, but, well, maybe we should. So over here, 72 is 2 times 36, which is 2 times 18, which is 2 times 9, which is 3 times 3. I have a pair of 3s. I have a pair of 2s. 3 times 2 is, I lost my C somewhere along the way. 3 times 2 is 6. And then if I don't have a pair, that stays under the radical. So that simplifies to 6 square root 2. All right, so now we're going to do it again. And we want to find the length of BD. So we say BD equals, okay. So it's the difference in the x's So 6 minus a negative 4 is 6 plus 4. Careful with your signs. And then the difference in your y's. 8 minus a negative 2 is 8 plus 2. So BD is going to equal 10 squared plus 10 squared. So BD equals 100 plus 100 square root, or BD equals the square root of 200. So when I do the square root of 200 and I do a factor tree, that's 2 times 100. That's 2 times 50. That's 2 times 25. And 25 is 5 times 5. So there's my prime factorization, pair of 5s and a pair of 2s. 5 times 2 is 10. That can come outside. And then what's alone stays under the radical. So as you can see, AC is 6 square root 2 and BD is 10 square root 2. They're not equal and they're perpendicular. So therefore this is a rhombus. And that's how you do a coordinate plane parallelogram identification. So now you should be able to do problem numbers 55 and 56 in the exercises. Okay, the sun just came around and is hitting my camera directly, so it kind of looks like I'm in a sun, one of those sun rays that are coming down from the sky, from the clouds. Okay, I'm a math god. So this brings us to the end of exercise 7.4. These are the problems that I have suggested you try and turn in. So there you go. Thanks for watching and have a great day.